talked about correlations, and we talked about error terms. So you've now labelled that entire document.
Yeah.
So what you want to do in this exam question is you want to describe the model using all those terms, using the terms latent variables, observed variables, factor loadings, regression paths, structural coefficients, or all of that. Structural paths, structural coefficients. All right, good. And that might take, I don't know, maybe a couple of hundred words or something like that of your 500, maybe 300 words of your 500, something like that. But then you want to talk about
Error.
Sorry?
Error terms? Error terms.
Oh, the error terms. Yeah, you talked about the error terms. I identified those, so you can talk about the error terms as well. That's all part of that first description.
Okay.
Good. So, in other words, you just label everything in this diagram and talk about it. Okay. Good. Then with your remaining 250 or so words, what you want to talk about is how we estimate this model. So all we've done so far is describe the model. That is, we've said what's in the model, what are the things that are in the model, whether they be variables or paths or whatever. Basically, you've got variables, paths, and error terms. That's effectively what you've got in there. All right, so how do we determine, well, what's the first step in estimating a structural equation model? So by estimating, I mean different to the estimating in the exam this time, unfortunately. Estimating the model means assigning the values to each of these paths. So assigning the values to the error terms, assigning the values to the factor loadings, assigning the values to the correlation, assigning the values to the structural paths, and assigning the values to the disturbance terms. Right? That's what estimating the model means. It just means assigning the values. Now, how do we assign the values to the structural equation model? Okay, so in the structural equation model, the first things we estimate are the factor loadings and error terms and correlations. Now I know that not all the correlations are marked here, and the correlations between the latent variables. So imagine that I've got this model, and I'm just rearranging this model. So instead of having that model up there, I've just got this model, which has got the 4 factors and so many items on each factor. However many there are, doesn't matter. Okay. So before we estimate that model up on the board, we always estimate this model. And this model includes all the error terms. Now this model has got everything in it that the other model has. It's just that it's arranged differently. Oops. And we estimate all the correlations here. I'm not going to draw them all in. Okay, maybe I will. Okay, there you go. We estimate that model. In other words, we just get that model and we arrange it like this to start with. Okay. Now, does anyone know what this model is called?
CFA?
Yeah, nice. It's called a confirmatory factor analysis model.
Measurement model.
Sorry?
Is it measurement model?
Also known as a measurement model. So it can be a confirmatory factor analysis model or a measurement model. It's the same, it's exactly the same term. It's exactly two different terms for exactly the same thing. Okay, the measurement model. All right. So before we estimate that thing, which is the structural equation model, we estimate this thing, which is the measurement model. Good. Which means we just put values on every one of these things. We put values on all the error terms, we put values on all the factor loadings, and we put values on all the latent variable correlations. All the correlations between these variables. Good. And that goes just all the way down for everything. Okay. Now, how do we estimate the confirmatory factor analysis model or the measurement model? How do we do that? Well, the answer is we run a thing called a confirmatory factor analysis. How do you estimate a CFA model? You do it by running a confirmatory factor analysis. Now, we haven't got to confirmatory factor analysis yet, and we're not going to get there until next year. So you don't have to tell me everything about confirmatory factor analysis. All you have to tell me is that the first step in estimating that model, the structural equation model, is to first estimate the measurement model or the confirmatory factor analysis model. And the way that we estimate the confirmatory factor analysis model is through confirmatory factor analysis, which is just another form of analysis, just like a regression analysis or an F-test or a T-test or something like that. It's just more complicated, but it's just another way of determining. Because what does a regression model do? When you run a regression analysis, it just tells you what the relationship between X and Y are. Yeah. Okay? It's just a way of estimating the regression model. So this is just a way of estimating the confirmatory factor analysis model. Good. Then, once we've estimated the confirmatory factor analysis model, we then rearrange all the variables so that they look like that, and then we estimate the what? The SEN, the structural equation model. Yep. And how do we estimate a structural equation model? Sorry?
Path analysis.
No, we estimate a path model using path limit analysis. So we estimate a confirmatory factor analysis model using confirmatory factor analysis. We estimate a structural equation model using structural equation modeling. That's exactly right, which is just a different version of confirmatory factor analysis. So structural equation modeling and confirmatory factor analysis, they use exactly the same software and they use the same sort of commands. It's just that we rearrange the model differently. So, the story so far is this. You describe the model. Great, you've got all the terms to describe the model. We then say we're going to estimate the model. How do we estimate the model? We use confirmatory factor analysis and we use structural equation modeling. Now, what is the point of, we know what the point of the structural equation model is. It's to estimate the values, you know, what are we really interested in, excuse me, what are we really interested in the structural equation model? In the structural equation model, well, what does the confirmatory factor analysis model give us? It gives us all of those, all the error terms, gives us all the factor loadings, and it just gives us correlations between these variables. What does the structural equation model give us?
Variables.
Yeah,
Latent
it gives you the causal relationship between the variables, which is not the same as the correlation between the variables. In exactly the same way as the correlation in correlation is not the same as the regression line in regression, the correlation between latent variables is not the same as the regression or the structural paths between the latent variables. Right? So the correlation coefficient in regression, the correlation coefficient and the regression coefficient are not the same thing necessarily. They might be, but not necessarily. Exactly the same here. The correlation between latent variables and the structural paths between latent variables are not necessarily the same thing. They might be, but they're almost certainly never are. They almost certainly never are. Or almost always never are. So the point of the structural equation model is to estimate all these paths in here, these three in particular. Because you already know what the correlation between cognitive and family is from your confirmatory factor analysis. Because there you've just got every correlation. So you must have that correlation. But what you're interested in is those three paths. So what you're going to tell me is that the primary interest in estimating the structural equation model is to determine the magnitude of the structural paths. Does that make sense? The primary issue in a structural equation model is to estimate the magnitude of those paths. Or in other words, how many structural paths do we have up here? How many structural paths do we have here?
6. Dia ada ni. 6.
No? 0. Who said 0? Right, 0. No structural paths. We've got error terms, factor loadings, correlations. No structural paths. Alright? We don't have any structural paths.
Correlation.
How many structural paths have we got up here?
3.
Right, well done. Okay, so the purpose of the structural equation model is to estimate the magnitude of the structural paths. That's the purpose of the structural equation model. The primary purpose of the structural equation model. Because for the confirmatory factor analysis model, that gives us everything but the structural paths. So it's the structural paths that we're interested in the structural equation model. Okay, so why do we do a structural equation model? Because we're interested in the structural paths. It's exactly the same as saying, why do we do a regression? Because we're interested in the regression paths. Alright. Okay. Now, given all of that, why do we estimate this? What's the point of doing this? Why don't we just do that? Why do we have to do that? Why do we do that first?
To check the validity.
Sorry?
To check the validity.
Validity of factors.
Right, well done. So it's actually what we're testing the validity of the measure. And the way we test the validity of the measure is by determining the size of the factor loadings. That's effectively it. All right. So in other words, we want to know, are these things measured by these things? Are the observed, one way of putting it, do the latent variables cause the observed variables? That's one way of putting it. The way we usually say it is, do the observed variables measure the latent variables? That's what we're interested in. Do the observed variables measure the latent variables? And how do we know if the observed variables measure the latent variables? Factor loadings, exactly. Now, if our factor loadings are all like 0.8 or you know, 0.7, even 0.6s, then we would say that the items measure the factors well. But if your factor loadings are like 0.2 or 0.1 or 0.3 or something like that, then we would say that the items do not measure their respective factors well. In other words, low factor loadings means the items don't measure their respective factors well. And if the items don't measure their respective factors well, then we say that the measure has low, you said the word before.
Factor loading.
No. If the factor loadings are low, if the respective factor loadings are low, other words, they don't measure their latent variables well, then we would say that the measure, meaning the items themselves, the survey, then we would say that the survey is not valid. Exactly. So the factor loadings, if you like, are a measure of the validity of this survey. I haven't quite put it in exactly the way that I would put it if I was writing a statistics exam, but that will do for now. The interest is, the reason we estimate this model is because we want to know, before we do that, we want to know whether the items measure the factors.
Yeah.
Now, why do we want to know if the items measure the factors? Okay, so let me just slow it down. We're estimating this first, this thing called a confirmatory factor analysis model. The reason we're doing that is because we want to know whether the items measure the factors. The way we know the items measure the factors is if they've got, measure the factors well, is if they've got high factor loadings. If they have high factor loadings, then we say the measure is valid. All right, lovely. We've got that far. Why do we want to know whether the items measure their factors well? Why do we want to know if the survey is valid or not? Why do we want to know if there are high factor loadings or not? Why do we care?
To carry on the research. It is not addition, we can provide with the model to validate the model.
Yeah, you're pretty much on the right track. What do we really?
To validate the strength of relation.
Yeah, we are doing it to validate the measure, but why are we interested in validating the measure?
To get the direct causal relationship.
Exactly right. If these factor loadings are terrible, then it's going to affect the estimate of those paths. Okay? If the measure isn't valid, then it's going to affect the values that we get for that. And what we're really interested in is knowing the values. What we're really interested in is knowing the values, right? And if we've got an invalid measure, that is poor factor loadings around here, then we can't be sure that the estimate that we have for those paths is the correct estimate. And that's what's that issue here. We want to know what's the true value of that relationship and that relationship and that relationship. If we've got junk around here, you know, poor measures around here, then we're going to get a poor estimate of those things in there. So the whole purpose of doing the confirmatory factor analysis is so that we get a correct estimate, or as good as we can get, for the structural paths in the structural equation model. That's why we do it.
So how do we get that 0.8, 0.7 from SPSS?
Sorry? No, it's not SPSS. It's a whole different statistical package that we'll be using, and it's a whole...
We are not studying now.
Sorry?
We are not studying that now.
No, you're not
How
saying
can we
now?
assign the values then?
Sorry?
How can we
You
assign
don't have to assign the values. All you're doing is telling me At the moment, you're just
Is
telling
he
me
talking
about,
over just the story? without-
you're just telling
without
me the
numbers.
story of the model. You're not trying to put any values.
All of this where you want us to.
All of these
estimate.
values will come next year.
It's not about talking about numbers.
No.
Like we did earlier.
Concept.
Yeah, it's not about talking about the numbers, it's talking about what this means. Yeah, there are no numbers attached to this.
But like, I was just curious, what would be like benchmark for being a high factor loading?
Oh yeah, normally, normally factor loadings below 0.5 we think are not very good, and factor loadings sort of above 0.8, you know, 0.7, 0.8 are pretty high. Yep. Just as a rule of thumb. Yep.
Yeah.
Okay, so this is the way the answer goes. You tell me about the model, you describe the model using all the terms, error terms, factor loadings, items. That. Then you say that you estimate the model using confirmatory factor analysis and structural equation modelling, and then you're going to tell me why we use confirmatory factor analysis before we use structural equation modelling. And there's piles and piles and piles of good stuff out there on the internet about confirmatory factor analysis, structural equation modelling, all of that. Lots of 6-minute videos, lots of materials. I'll send you a couple of resources, you know, tonight or something. Now, last little bit for this one. First of all, any questions about any of that? Okay. Why is this question in the exam in the first place? What's the point of having this in the exam in the first place?
It has a relationship with it has a relationship with
Biggest
what Mariano was talking about.
Right, exactly right. This is how we're going to estimate, or all of you are going to be estimating your own structural equation models in your research. Every one of you is going to have a structural equation model with certain variables in it, and you're going to be estimating your structural equation model, determining whether your items are valid or not, working out what all the coefficients are, and writing up a thesis about it. That's basically everything that you do for the next 12 months is going to be built around your model. Yeah. And if you go on to do a doctorate, then the next 3 years, 4 years, whatever after that, if you do it in this field. All right, so in answer to someone's question of, I don't know, a couple of months ago, are we going to be doing t-tests and things like that in your thesis? No, we do all of that so that you can learn about statistics. What we're going to be doing in your thesis